Imagine having unlimited high-quality AI text-to-speech without paying a monthly subscription or worrying about character limits. Today, I'm going to show you how to use Qwen3 text-to-speech. We are running this entirely locally on our own computer using Pinokio. I'll walk you through everything, from starting the app, loading the model into the GPU, designing the custom voices, and even cloning your own voice. So, first things first, let's get the engine running. I'm assuming you already have Pinokio installed. If not, have a video on how you install Pinokio on your PC. I'll also have some links down in the description. In my case, I'm doing this on Windows because this is what has an NVIDIA GPU, but this can also be done on Mac. There are GitHub repos for Qwen3-TTS for Mac. I'll include the links down in the description. So the first thing we do is open Pinokio, as I have done on my machine, and I have Qwen3-TTS installed. I'll click on View so that it starts the process, and then I'll click on Start. Now, this initiates a terminal window. Worry not, this is just the backend server starting. This might take a minute or two depending on your computer, but once it does, you'll see an option to load the web interface. The script is done. We'll head on over and click on Open Web UI. So this is the Qwen3-TTS web interface. The first thing we do is download the specific models we want. We can choose the type as well as the size and then click on download. As you can see, I have some models downloaded. Now, what you do is you just choose the specific option that you want. I'll assume you want to go with maybe voice design. So you can choose voice design and there's a drop down under size. This is only available in 1.7B as the size. I'm guessing that is 1.7 billion parameters. So I already have that downloaded. As you can see, the model status on the right. Under the base model, I have both of them. There's a 0.6B and 1.7B. Now, 1.7B is obviously bigger than the 0.6B, and it just depends with the resources on your computer and mostly the size, because they differ in sizes and the results will be different. So as you can see on the right, I have the 1.7B under this design. I have both of them under the base or this cloning model. And then custom voice, I have one. I didn't download the 0.6B. I didn't see the need to. These models are huge. As you can see on the left, everything I have under Qwen3-TTS is around just over 24 gigabytes. So next, we have the option to load models to the GPU. Now, once you've downloaded everything, the next thing we do, we need to load the models onto our GPU so that they are easily accessible when we are doing the voice design in this example. What we'll do, head on over to the type. I already have voice design. I'll choose the 1.7B and then I'll click load to GPU. Now for us to monitor, I'll open my task manager over here and head on over to my GPU, my NVIDIA GPU. And as you can see, once the model is loaded onto our GPU, there is a spike in usage. So we were initially using nothing on the dedicated GPU memory, and now we're using close to maybe just under 6 GB of VRAM. So in this panel on the right, we can see the status. It says the current model that is loaded onto our GPU is voice design 1.7B. The next tab is unload model. So once you're done with the model, you have the ability to unload it and load the next one so that it's easier on the resources on your computer. We're not using this for now. So since we've loaded voice design, I'll head on over to the voice design tab. So under voice design, you're the director here. You don't need a microphone. You just input how you want the voice to be. You describe the voice and you give it instructions on what to say, how to say it, and voila, you have your results. So under voice design, we have the text to synthesize. So this is the text that you want to output. And then we have the voice description. This is how you sort of direct the voice and how you want to say the tonation and all that. We have language and then seed. So in order for us to test this, I'm going to write a prompt. So let's say a clear, confident, professional male voice speaking at a moderate pace suitable for a tech tutorial. So once we have the description and the text to synthesize, we can go ahead and click generate. Now, as this is generating, the speed at which this is done is heavily dependent on the resources on your computer, as the video memory and the CPU that you have. So it differs on the time it takes to process, but just give it some time and it will be done. So there we have it. It's done processing. We can listen to the audio.
Welcome back to the channel. Today, we are going to build a computer from scratch.
I believe that's clear. That's awesome. You can't even know that was generated artificially. So that's clean. That's clean. Next, I want us to challenge this. I want us to give it maybe a fantasy character. So I'm changing the text to something out of a movie, let's say, and it reads, "You must not touch the artifact. It contains magic too dark for this world." Yeah, it's awesome. So let's give it a description. Our description reads, "An elderly wizard with a deep, raspy voice, speaking slowly and mysteriously, echoing slightly." Notice how I use the words raspy and slowly. We're trying to see if the AI understands texture. So let's click on generate. And after a while, that is done. So let's listen to this.
"You must not touch the artifact. It contains magic too dark for this world."
Yeah, that's pretty good. That's pretty good. So under voice design, as I said earlier, you're the director. You instruct the AI on how you want the voice to be. You can choose the accent. You can choose the pace. Different things. Just how you want the voice to appear. That's what you use voice design for. So after this, the next thing we do is head on over to voice clone. But before that, we need to go back to our models and unload the voice design model. So under unload models, I'll choose voice design and then unload selected, or we can just choose unload all. If you have a GPU that has more memory, you can load multiple models. But in my case, since each model is using somewhere around just under 6 gigabytes of memory, and that's all I have here. So I'll unload the model and load the next one. So I'll click on unload all, and our model was freed from the GPU. When we refresh, no models, and even when we refresh the models, no models. So the next one, we choose base. Base is simply voice cloning, and I'll go with the 1.7B for more accurate results and load these to our GPU. Once again, if we monitor our usage over here, as you can see, the spike was when we were using the voice design model. When we unloaded, the usage decreased. And now that we've loaded another model, as you can see here, successfully loaded the model, our usage has spiked again. So let's head on over to the voice cloning tab. The voice cloning tab, basically, it's simply what it says. You import, or rather upload, a voice, maybe 5 to 10 seconds of an audio clip, and you give it the reference text, maybe what you said in the audio, and it will generate something similar based on what you say. So under here we can see the reference audio. This is the audio you've already pre-recorded. We'll upload that here, the reference text. So what he said in this audio, for it to know the words, the tonation, and everything. And the best thing to do, you can type it, since they give you the ability to do that, but it's pretty good at transcribing, so it gets nearly everything okay. So that's the best thing to go with. And then we have the target text. Target text is what you want it to say using the cloned voice. So I'll upload an audio over here. I'll go with this. I'll listen to it. It's a bit lengthy. It's around 26 seconds.
Today, we are learning about Qwen3-TTS. Qwen3 is an open source model from the Alibaba group.
So I can choose to trim this, say, talk with that. So
Qwen3 is an open source model from the Alibaba group. It is a suite of speech generation tools that can do voice cloning, custom voice design, and ultra-realistic human speech.
So that is our uploaded audio. So the next thing we do is click on transcribe. We can either type what we said, but it's pretty accurate. So I'll just click on transcribe and it transcribes the clip. You've cut around 10 seconds of it, so should be pretty fast. So here we have the audio. So I'll just correct a couple of things. When there is an open source model from the Alibaba group, it is a suite. So let me correct this suite of speech generation tools. I can do voice cloning, custom voice design, ultra realistic human speech. So it's pretty accurate. It's not bad. Now, since we have that, we can enter our target text. So it will use my voice. That was my voice we had, and try to clone it with some new text. So there we have our target text. It says, I can't believe how easy it is to clone voices inside Pinokio. It's totally running locally. Now, there are a couple of things you can choose to change inside voice cloning. For example, over here, we have chunk size, which by default is around 50, and the chunk gap, which is in seconds. So let me explain the difference. Chunk size is the byte size. This basically determines how much text, or rather how many seconds of audio, the model processes in a single pass. So it tells the AI only look at these many words at a time. If we set this high, the AI has more context. It understands the flow of our paragraphs better, and this gives it a more natural sort of intonation. Keep in mind that this uses more RAM, and the longer the paragraph is, the AI is more likely to hallucinate and start saying its own things. If you set the chunk size to low, the generation is a bit faster, more stable, but the voice might sound somewhat disjointed because the AI forgets what it said in the previous sentence. Next, we have the chunk gap. Chunk gap is maybe the overlap, and it determines how much of the current chunk looks back at the previous chunk to ensure a smooth transition. Basically, it forces the AI to look at the last few words of the previous chunk when starting the new one. It ensures that the speed and the tonation and the emotion match the previous chunk of words, and when you stitch those two together, there's a flow basically. If we set the chunk up to high, the transitions will be seamless and you don't hear stuttering or sudden voice pitching. And if we set it to low, you might hear sudden change in speed and tonation in the middle of the paragraph because the new chunk is treated as a completely different audio. I tried to explain it as best as I could. I'll just go with the default settings over here, and let's listen to how it produces this. So it's done processing. Let's listen to the results.
I can't believe how easy it is to clone voices inside Pinokio. This is totally running locally.
I believe that's pretty close. I've had my voice a couple of times, and I'd say that's me. I'd say that's me if I had that somewhere. So that's voice cloning. Now it's not perfect like one-to-one, but it gets the job done, especially on short sentences. It's pretty good. Now, next we have the custom voice tab. But then again, before that, let's go and unload the voice clone model and load the custom voice. So head on over back to unload models, click on unload, or go back to load models, load the custom voice. I'll go with the 1.71 again for better results. I'll load that into our GPU. So it's loaded. You can click on the custom voice tab. Now, the custom voice tab gives you the ability to take a preset speaker profile and modify it using instruction control. The Qwen team released a document on the different voices, and they've basically trained voices and the ethnicity. We have some Chinese speaking profiles, English speaking profiles, and you can use this. So you basically take a voice, say like there's a voice called Ryan, and you give it specific acting notes. It uses instruction following abilities to change the speed, the tonation of the specific voice in real time. So when we take a look at the layout, at the top we have text to synthesize. So this is the text you're giving it. the one that will be generated in the audio. We have the speaker, we have a couple of speakers here, and it's wise to refer to the document so that you know which model the speaker was trained on, because we even have Chinese speakers over here. So we have the English, the style. This is when you describe the situation and how you want the voice to be done. Somewhat similar to voice design, but over here you have a specific speaker for specific situations per se. So let's give it some text and see how it does. I've given it an overjoyed situation where someone is happy about their YouTube subscribers, and I'll try the Serena voice. Now, the Serena voice is natively Chinese from the blog post by Qwen, but you can tell her to speak in English and hear how the accent is and how the results are. Let's listen.
I just checked my dashboard and we finally hit 100,000 subscribers. I'm so incredibly thankful for every single one of you.
Now that's good. That is good. You can tell the accent. You can also hear that her pitch rises. You can almost tell that she's smiling. So let's give this a try with somewhat of a native English speaking voice with some different instructions. So in this particular case, I've given it the text to synthesize, obviously, but I'm going with Ryan, who is a native English, which is a native English voice, calling them people. And in this particular situation, I've given the instructions to a whispering, secretive, urgent tone, speak softly. Let's generate this and listen to the results. So here we have the results. Let's listen to the results.
I can't believe they actually left the door unlocked. If we're quick, we can grab the files and get out before the guards return.
Yeah, that's pretty awesome. That's pretty awesome. As you can hear, Ryan is a native English speaker. You can hear the tonation, you can hear the lowering of the voice. You can almost imagine the situation they are in. So there you have it. That is how we run Qwen3-TTS. Give this a try and let me know your findings. If you like the results or not, if you encounter issues, drop that down in the comments and we'll all try to help. Don't forget to like this video, subscribe if you haven't, and I'll see you on the next one. Cheers.